Good morning. I'm going to run through the expressions task with you very quickly since we didn't have time to do that in class. Translate the following verbal expression to a numerical expression, the square of the product. So because it says it in that manner right there, the square of the product, we're going to be putting that product stuff inside parentheses. And the square means it's to the second power. The numbers we'll be multiplying would be 4 and 5. Next word we have is minus, so that's a subtraction. The quotient of, so put that in parentheses and we know the operation will be divide, 6 and 3. Then for part B it says evaluate that expression in part A showing each calculation. So I'm going to rewrite this. And then the first step we're going to do is work our parentheses from left to right. So that will be 20 to the second. I do not have any operation inside that parentheses left. I've done what I can there, but I'm leaving it there so I know that that is 20 to the second power. Still need to do parentheses, and the operation inside there is divide, so this is 2. Next, after parentheses, we've done that, is exponents. So let's do exponents next. 20 to the second power will be 400. That's 20 times 20. So I've done exponents. Multiply and divide, I didn't have any. And add, subtract is what I do next. And that is 398. Over on the back, Carla wrote a different numerical expression for the expression given. What correct expression could she have written? We came up with several for these. Well, 4. So the first one that we came up with is 6 minus 2 plus 4 times 5 to the second power. And the justification for that down here in D part is the commutative property of addition allows us to add in any order without affecting the sum. All right, the second one that we came up with was this. Here, from the 5 times 4, we changed this to 4 times 5. The justification for that is the commutative property of multiplication. Allows us to multiply in any order without affecting the product. All right, for C, the third option that we came up with was to break down the product of 5 and 4 squared to this. That's times 4 inside those big brackets. So for C, our justification is to square something is to multiply it by itself 2 times. And then the fourth option 5 times 4 to the second power plus 6 plus negative 2. And our justification, subtracting is the same as adding.
Teachers, you can go pick up your...
Adding the opposite. And there could be some other options there, but those are the 4 that we came up with. And if you came up with something different, I'd love to hear about that. Alright, so the absolute value task. When did it hit this one too? 1 week during the winter, the temperature ranged from -5 to -15. Draw a number line or thermometer to represent the high and low temperatures in that week. Include 0 in your model. So if we're talking about a thermometer, 0 would be here, and we're talking about degrees Fahrenheit. And if I counted by 5s, this would be -5, this would be -10, and this would be -15. Up here would be +5. And we can put our Fahrenheit here. So there's our range. Complete the inequality using less than or greater than. The absolute value of -15, how far away is that from 0? How much value does that number have? It's 15. The absolute value of -5 is 5. The distance from 0 is 5 for that one. Okay, so 15 compared to 5, this is greater than. But if you look at -15 compared to -5, would you rather be at -5 degrees or would you rather be at -15 degrees? I prefer to be a little bit warmer. -5 is warmer than -15 degrees. So then on the back, skiing is possible when the temperature is at or below 20 degrees Fahrenheit. Is -5 or -15 degrees Fahrenheit closer to 20 degrees Fahrenheit? Justify your answer using mathematical language. You may use one of the inequalities from Part B to support your justification. Okay, so we could say that -5 is closer to 20 degrees Fahrenheit because it is closer to 0 than the -15 degrees Fahrenheit. Okay, and here on your number line, if 0 is on the middle, you got 20 degrees over here. Here's -5. So the distance from here to here is greater than the distance from here to here. Tess and Jayla discuss absolute value. Tess says the absolute value of -5 is -5. Jayla says the absolute value of -5 is 5. Who's correct? Jayla is correct. The absolute value of -5 is 5. The absolute value of a number is its distance from 0.